Welcome everyone. So this video is going to kind of walk you through how to go through the first lab of the year, which is going to be us mapping the motion of a buggy to see if it is going at a constant velocity or not. All right. Now you'll remember that the first part of this lab is actually the pre-lab. So all the section that I've currently highlighted right here is a section that we have already covered in a previous video or we have covered in class. So if you've not already filled that part out, I would highly recommend going through, watching the video that I believe is talking about the first demonstration for this constant velocity unit. Go through and then you will be able to fill those things out. All right, so moving forward, we've kind of talked about our pre-lab. We'll remind ourselves that the purpose of this particular lab is we're hopefully going to prove that the constant velocity buggy that we're looking at is moving at a constant speed. Now, whether or not that's true, we're going to find out, and that's exactly why we're doing this lab. So, in order to do the lab, I'm going to tell you to kind of do a couple things so that you don't have to watch the whole, expect me to walk you through the whole thing in the video. What you'll need to first do is you need to go to week 2. You need to hopefully already have the mapping motion constant velocity buggy lab Google Doc open. All right. Next, what you need to do is you are going to use a website that's called JS Track, and this is going to let you map out the motion of our cart using kind of the oil drop, the breadcrumb method we discussed in the previous video. So if you want to already know how to do it, you're welcome to watch the video that Ms. Fumia has made explaining how to use JS Track, but I'm going to briefly just kind of touch how you're going to use it for this lab. So you're going to open up JS Track. I would more than likely just probably open it up so it's an entirely new window in and of itself. It'll look just like this. What you need to do next is you then need to pick one of the 3 car videos that you're going to analyze. Doesn't matter which one, just pick one of the 3. I've already picked one, so what I'm going to do is you download that video, you're going to say select local file. All right. Now, as I will, you get to see all the things I have downloaded, but this is the one I'm going to use right here. So you select the file. It'll take a second to kind of load what's going on. And then once it loads, it's going to ask you to do a new project. All right. All you need to do is first name it whatever you want. It does not matter. I'm just going to call it test 1. Next, you need to change the frame rate. What we're going to do is the only thing you need to shift out of all this stuff is just the frame rate, and we're going to make it 4. All right. That means it's 4 frames every second. So every frame, the car is going to move forward 0.25 seconds. All right. Now, once you do that, you're going to hit create, and you'll notice that now the axes have shown up on the screen. All right. What you're going to do is you're going to move the axes around, so you just kind of drag them around the screen, and you're basically going to move it so that there's now one axis at the y-axis is now at the origin, 0 meters, and the x-axis is basically splitting the car in half. So it looks like that's the path the car is going to travel. All right. Once you've done that, in order to actually collect data, you need to do 2 things. The first thing you need to do is to make sure that the data matches the actual scale on this video. So to do that, you go to the upper right hand corner to these 3 little dots. It'll say create scale. What you're going to do is you're going to click create, and then you're going to notice your mouse is turned into a little box. You're going to first click the front meter stick, and then you're going to again click the end of the meter stick. And what you've done now, if you have actually set the scale for this situation. All right. Now, this scale automatically looks like set itself to 1 meter. It's really going to be up to you to do that. It'll ask you to type in what the scale is going to be. This is 1 meter. And what it's done now is it's going to set all the data so that it now matches the scale you've set. To actually collect data, you're going to then click the little mountains up here in the right corner where it says create new track. Again, does not matter what you name it. I'm just going to call it test 1. And you're going to click create. Now, what this allows us to do is we are actually able to now start putting the dots to kind of signify the car dropping oil every quarter of a second. So what I'm going to do is in order to collect data, you need to hold down the shift key. Once you do that, you'll notice that the axes go away, and now my mouse turns into this little box with the target in it. I let go of it, it disappears. So I'm going to hold down the shift key, and I'm going to click literally right at the front of the car. All right. I put the first data point, and you'll notice now the car has moved forward 1 frame. I click again, and you'll notice now the car starts to move forward. And what you're going to do is you're going to keep clicking the car for several data points. It really doesn't matter how many you get, as long as you probably go, you need at least 7, I believe is what I said in the lab, but honestly you can go as many as you want to see if it's consistent or not. After you've got enough data points, what you can do is just let go of the shift key, and you'll notice that the dots that you put down start to appear. All right? Now, at this point, you have the data you need to analyze. You need to record it into your lab. You then need to start answering some of the questions. All right? Now, what I'm going to tell you is that all the directions for this, because this is about the point where I'm going to say you can stop, listen to me, and I'm actually going to skip towards the end. So what I need you to do is you need to go onto Canvas and click where it says Directions for Lab. This will walk you through what you need to be doing for the data collection parts of the lab. You're going to first collect the data, then you're going to create a graph, then you're going to actually find the line of best fit for the graph. All right? So, with that being said, I want you to pause the video at this point because you are actually going to be doing the lab. Once you have all those things and you've completed all the directions for the lab and you've gotten to the point where you actually have a line of best fit, you then can restart this video and we'll talk about what we should have seen. All right, so at this point, pause the video if you don't mind, work through the lab. Once you're ready, unpause it and we'll finish it up. All right, so hopefully you had a chance, ladies and gentlemen, to kind of work through this lab and see some of the things that we were trying to prove. If we review what's going on, hopefully your data showed a couple things. You might have seen the first thing just looking at the data. You probably noticed that the dots, just literally looking at the video, probably look like they're pretty consistently spaced, give or take a little variation just based off the fact that you're trying to click something. You also probably noticed that if you looked at your data, there's probably kind of a constant increase in the position of the cart every quarter of a second. And right away, that's some good evidence that maybe this is proving our point and it is going at a constant speed. Once you graph it, you hopefully have a graph that kind of furthers this, because what you've probably seen is a graph where it is creating a linear trend, which means that basically, again, we have another piece of evidence that tells us this is going at constant velocity, because every second, the motion of the object increases the same amount, or the position changes the same amount. So it's a nice consistent ratio, which tells us that it's probably moving at a consistent rate. All right. Now, finally, you also were able to actually create the line of best fit equation. And that actually has physical meaning for us. What we're going to find out in physics is that a lot of the things that you've used in math before are actually really important when we look at data and try to explain how the world works for us. So things like taking the slope, reading the graph, physically mean something for us. So with the line of best fit equation, hopefully you've written it down in your lab. You write down your car. The other two cars that you did not pick, I'm actually just going to list all 3 of them, and I'm only going to say them out loud. So you listen. You can play the video back as many times as you need to get these written down. So if you need car number 3, the equation of the line for car number 3, I believe, was 40 centimeters. Car number 8, I'm sorry, for car 3, it should look like y equals 0.4 x. All right, and I found the reason it's 40 centimeters per second is because that would be the scale if I used it in centimeters. So that would be for car number 3. For car number 8, it's going to be about 0.35. And of course, at any point in time when you're doing these, if your data is a little bit different than what I got, that's not a bad thing. That's science. You're going to have a little variation. All right, that's for car number 8. And then for the third and final car, car number 9, the slope is about 0.2. All right, that's for car number 9. Now, looking at those 3 things, it's not super easy to figure out what's going on at first, but if you watch all 3 videos and you look at how long it takes the cars to travel the same distance, you might see that the slopes seem to correspond with how fast the cars are moving. All right, which means when you compare all the cars, the slope actually represents the speed itself. All right, now What that means is that if you have a car that's moving very fast, if you looked at the graph, it would have a very steep slope because it would be increasing its position a lot every second. And then if you had a car that was very slow, the line would increase, the slope would be very small because it's not increasing position much as it moves forward. So that leads us to kind of to wrap up the final part of this. First, did we satisfy our purpose in this lab? The answer to that is we did, and we talked about it kind of periodically throughout this lab. We talked about the idea that we have several pieces of evidence that back us up. We can talk about the fact that we can visually look at the dots and see that they seem to have a consistent separation for every quarter of a second. We also looked at our graph and saw that our graph had a linear trend, which tells me that the position increased at a consistent rate every second. And then finally, we can look at the fact that we can actually calculate the speed, and it tells us that the speed is not changing because the slope is consistent. All right? So those are just some pieces of evidence we have that we satisfied our purpose, which is perfect because that means that now we can start to map out what's going on when things are moving at a constant speed. And finally, just to remind ourselves, the slope of position time graph represents the speed of an object. All right, how steep that graph is represents how fast the object is moving. The steeper the slope, the faster the object. All right, so with that being said, ladies and gentlemen, that kind of covers the very first lab of the year. It gives us kind of our first step into how we can analyze motion of objects. So as we kind of move forward, we're going to keep coming back to the ideas we talked about in this lab as we start to look at more and more complex motion. So with that being said, once you're finished with your lab, just please submit it on Canvas. Otherwise, have a great rest of the day, and I'll talk to y'all later.